I want to talk a bit about this beautiful thing today. How many of you have heard of the HoloLens? All right, cool. All right, good start, good start. How many have tried it? Ooh, even better. How many have developed for it? Yes! If you've done any kind of development for it, it might have been a bit boring, and I would have recommended going to my second talk, which is immediately after this. So, but yes, I did mean to say bedroom. People go, did you mean robot? Snicker, right? No, yeah, that was a bit of a play on words. So, I live here in Australia, and I came just for you guys. I am actually dansk for København, but I live in Australia, right? So, this is my backyard, kinda. But it's not like we don't want people to come to Australia, right? We have warning signs. Have you ever seen a drop bear? You have? Liar, because you would be dead. Yeah. Drop bears, they look like koalas, but you don't really know until they attack you, right? So our government made this nice warning sign. It's kind of like the cigarette packages, right? And right now in Australia, we're going into summer. So it's starting to heat up a little bit. I was looking yesterday, and it was -2 here, I think, and it was 27 at home. So yeah, I've sacrificed a lot, I'll say. This is pretty much what it feels like in summer, because you still dress the same when you go to work, right? And it's crazy. Please don't be these guys. Or I could say, as I normally do in other countries, please don't be so Norwegian, right? Please ask questions. Just jump up. Just raise your hand. I'm okay with questions. If you run out of time, or if you're running, a bit late, I'll let you know, okay? But we'll get there. So what are we actually looking at? So a bit of where we are at now, which is so how many people here write code, like day to day? Almost everybody. Okay, that's cool. Because no matter how you look at it, all of that code kind of comes in the same way, right? You might be writing apps for a mobile device on a screen, right? It's still on a screen. You might be writing for desktop, which could be web, or it could be your WPF app, or it could be your whatever, Linux app, anything, Mac OS. It all comes out on a 2D screen, right? It's a flat screen. Kind of see where I'm going with this, right? You might be, does anyone do gaming? As in write games, yeah? Excellent. So, you don't write games, but you play games, okay. No, that's fine. I didn't ask that question very well. But if you write games, it's still for a 2D sit down, at a screen type thing, unless you still use the Wii or the Xbox Kinect, which I don't think anyone does after day 2. Like the Kinect is brilliant. It's actually kind of almost what's in here, but it's just not something that's used a lot. And then of course, collaboration. And finding pictures of collaboration is really interesting because people always sit around a screen and pointing. I don't know, is that how you collaborate? But the same idea persists. You have flat screens, right? And to be honest, it's a bit predictable. It's a bit boring. Like you kind of go on autopilot. Yeah, it goes out. It's going to be flat. We're going to have a thing up there and a thing out here, and we're going to, it just becomes the same over and over and over again. It's a great GIF, isn't it? He's done that before. And then, because it's like this, we tend to go completely the opposite direction, right? And we take this VR thing, and it doesn't work because it's there we go. And we take this virtual reality and we just scare the bejesus out of people, right? I don't want that shit. I don't want that in my VR headset. Has anyone ever played Doom on like the Oculus or the Vive or something? Like the original Doom game? Okay, good. Don't. Like, it's freaking scary. Like you need brown underwear for that. So this is kind of what we went from the 2D to the everything in your face. And yeah, there's good examples of it where we can extend on existing kind of experiences, and that makes a lot of sense. To me, it's taking something we already know and extending it into virtual reality. That makes a lot of sense to me. Now, talking about this thing, see, someone's played Sonic here, I can tell. Do you know what is actually powering this? Anyone? No? I found out. Magic. It feels like magic. If you try it, and I'm happy to give people a go if there's time, like in between talks or after the next talk or something like that. Happy to share. If you break it, you buy it. But it feels like magic. It really, really does. So let's talk about the different kinds of virtual reality, or augmented, or mixed, or digital realities, as I like to call them. Augmented reality, we kind of know. Whether we think we've tried it or not, we probably have tried it. And it's an idea of having the real world and you overlay some data on it. It's kind of like a heads-up display, right? I put an iPhone 8 on there at the bottom because the new AR kit, augmented reality kit for iOS is coming out, and it's going to work on iOS 11, which is with the new iPhone 8, which is very exciting because they do some really cool stuff with just the camera on the phone. We won't talk about AR kit today, but just so you know, it's coming. Well, it's here, but it's coming in production in more and more things. It's very simple, very lightweight often. It's a very basic experience. People always say, oh, I know what that is. It's Pokemon Go. And then I usually just throw them out. You know, Pokemon Go is not really augmented reality. It's kind of a real world camera with a thing on it. And you just do, it's getting there. People know now what Pokemon Go is, but to me, it's not the real use of augmented reality. It does often involve a mobile device because it's, you know, the real world. You move around in the real world, so you have your whatever device with you, which is often a mobile. And there's no obstruction reality. You can see all of the reality and you overlay data on it, right? So it's not VR, because VR, in comparison, you obscure everything, right? There's nothing left of the real world, hence the term virtual. So you're in control of what the user sees, of the full experience as a developer or a designer. It does come with very limited physical movement because you can't see where you're going, right? There's some assistance now with the HTC Vive, and the Oculus has some, you know, monitor or cameras that you set up in your space, and it'll tell you where they are, so you kind of can see a little bit about where you are. But you don't know if someone is going to step in front of you, or like you can't see the real world. It means it's quite isolated. There is some effort around collaboration and online gaming and those sort of things, but most of the virtual reality experiences are very single user. It's tethered, means there's always a cable coming out of your head. Okay, I brought this, which we'll talk about a little bit later, which also has a cable, but it's not VR, so everything is changing, right? It's a little bit different. But essentially you have a long cable that comes out of your head, and you're restricted by that. And that goes into a computer that's really, really powerful. And I've written no tracker movement, which used to be true, but there are now examples of tracking the movement, or the hand gestures at least, of whatever it is you're doing in this virtual reality. So that's kind of the two sides, and then in the middle is what's now termed mixed reality. And that's Microsoft's way of saying, no, it's not augmented reality. We want to call it something different, which has confused everybody. I'm okay with you calling it augmented reality, what works on HoloLens, but it is officially called mixed reality, right? The whole idea with this device is that it scans the room you're in, and I'll show you this in a little bit later. So you know, the device knows the entire 3D model of the room you're in, whether that has tables or chairs or people or whatever. It scans it continuously, which means that you have this natural interaction between the digital stuff that you put on the experience, which might be a person that comes in and sits on the chair, the real chair, and the physical world that you're in. So you can use any room, any surface. This is key. You have to be able to use any room or any place, any location that you can think of, right? That is the key for mixed reality. Because sometimes I've had questions like, but there's 4 chairs there. How does the next person know in the other room there has to be 4 chairs there? And no, you're missing the point. Whatever it is you're developing has to work with whatever is there. Whatever surfaces you identify, you have to use. So that's the key. There is no tethering, right? This is a complete, fully self-contained device. It has a computer and everything. So we'll go through that in a minute. Now, this is a really important question that if I talk to anyone, clients, customers, students, whoever, before you start developing whatever your great idea is, you have to ask yourself whether it is for HoloLens or it is VR, AR. Because you can absolutely build a VR experience on the HoloLens. Yeah, there's a Walking with Dinosaurs app that gives you this nice, beautiful world of palm trees and dinosaurs and everything, but it's not mixed reality, right? It doesn't take into account anything that's in the room. So don't do that. Make sure that if you build for HoloLens and you make people pay $3,000 US for one, that you also take advantage of what it can do. Because that often gets neglected. You just go, oh, that's cool, build that, and off you go. This is kind of the first prototype photo that I can find. I cannot verify that that is the HoloLens on the left, but I think it is. Also because it's the same dude. That's the Kinect from an Xbox 360 on his head. And these, it's kind of a bit hard to see with this, but they have red, green, and blue lenses here that can kind of go over each other, which this also has now in a much more complete package. And it's just interesting seeing, I'm guessing there's probably 4 years between the two photos, something like that. It's a fair amount of effort. So, just before we look at coding and stuff, the specs on this. So, it's kind of awesome and kind of standard. It's an odd mix. So, what makes it possible to scan the room that you're in are these 4 environmental cameras on the front. There's 2 on either side. They use infrared and UV light to map the room and build a 3D model, a polygon model, which also means it doesn't work very well in the sunlight because of the UV. It's not really an outdoor device. It has a depth camera that can measure, distance and depth, of course. And the UV is about 4 meters distance of the range, so you have to walk around a room to kind of map the whole thing. Has a video camera because you can record whatever you see, which I also use to show you what I see through it. And it has voice recognition through these microphones. It has incredibly good voice recognition. It's really, really, really accurate. I did a workshop the last 2 days on developing for it, and we had lots of fun with the voice recognition because it just works, right? It's so easy to use. Then we have the waveguides, and what you see is not projected onto your eyes or anything. You don't have lasers going in through your skull. It's just light kind of emitted from this angle down onto these waveguides, red, green, and blue, and that's how it builds up the holograms that you see. Very, very smooth, very, very fast. Limited field of view, we'll get back to that. That's usually what people go, And of course, it has some guts, it has a brain, right? I'm not a hardware guy, I'm not sure what an Intel Cherry Trail system on chip is, but apparently it's quite ordinary. There's nothing special. It's a 32-bit architecture. It does have a HPU, which is a holographic processing unit, and they've got that directly from Star Trek. No, not really. But that is what does all the holograms. And it's a bespoke piece of silicon that is built, I think Intel has built it, and it does something like 1 trillion calculations a second, about the same as a really, really powerful graphics card. 2 gigs of RAM, which is kind of meh. 64 gigs of storage, and it runs Windows 10, because it's a Microsoft device, right? And no, I have not had a blue screen yet. But it runs Windows 10, which means it gets the same updates as your Windows 10 laptop. But of course, it's a different version of Windows 10. And the last thing, which is a very, very big part of this, is the audio. It's got 2 speakers on either side, those red bits that sits right over your ears. And we'll get to what HRTF is, head-related transfer function. But that means that you can hear 3D audio with these speakers. It's very, very accurate. All right, and I would like to hammer this home. It's untethered, right? There is nothing else. This is it. So, often you'll see stuff like this. This is Microsoft marketing going, yeah, well, obviously it's Australia because she's being eaten by a shark, right? But you see stuff on the ground, there's stuff on the wall and things floating in the air and everything. And you kind of think that is the experience you're going to get. And it's not, right? It's more like this, okay? That's the field of view. That's where you see through it. And this is very disappointing if you expect the other picture that you see everywhere. You get used to this real quick, 15, 30 minutes. It's kind of, but it means you do move your head a lot. That's why people always do this, right? When they look at it, because you can't see very much. The holograms are only rendered in this little space. So that's the caveat there is. All right, I just want to show an example of something that's really cool. And it's, see if I can start it. Is this going to start there?
Zach grabbed his Xbox controller to play through a giant holographic portal into a 3D Minecraft world right on the wall. Even though I don't have a HoloLens, I'm able to play together with Zach from my Surface.
Are you going to come join my game, Lydia?
I'm in now.
I see you, jumping around.
One of the cool things about HoloLens is that it lets you display Minecraft virtually anywhere. You can get different perspectives on your Minecraft world. It's awesome to play with the controller, but can we show them something new, Sax?
Sure. Just take that experience off the wall and then put it on the table over here. Create world. see Lydia way up there.
As I run around the place, Zach can easily navigate and manipulate the world using his voice and his hands. He can walk around the hologram, pan around for different viewpoints, and even look inside.
That's pretty freaking awesome, isn't it? Like, that's, holy crap. Like, you look at this, you go, okay, that's pretty cool. Now, that was in 2015, and Minecraft is still not out for it. But anyway, you get the idea. There's this really, really immersive, even collaboration between the two. And he used, it probably was a table that had to be exactly that size, but the idea is you can use any table to do the same thing, right? So pretty amazing what you can achieve with it if you kind of have the vision of it. And then again, this is an existing idea that's been promoted and extended to work on the HoloLens. Okay, let's talk about code. So there's 5 building blocks, or 5 pillars of mixed reality development that you need to be aware of and need to get right for your experience to be kind of convincing, I guess. The first thing is what's called gaze. And gaze is essentially your mouse cursor. But gaze is where you're looking. Well, it's not so much where you're looking, it's where your head is pointing. So it doesn't track eye movement, but your gaze is what comes out exactly from the center of the HoloLens, right? So I'm choosing things, maybe, oh, there we go, as with my mouse cursor, but I'm using my head as the mouse. Okay, that's a little bit weird when you first do it, but that's how that works. You have a construct at the very core of it called raycast, which is what that little word says down there, raycast. And it's a Unity, so Unity 3D is the 3D modeling tool. Has anyone used Unity 3D at all? A couple of people? Okay. It's quite daunting using it the first time, but my approach had been just ignore everything you don't know what it does. And if something breaks, you figure out what that thing was that you need to know about. But raycast is a construct in Unity that allows you to kind of shoot a ray out from an object or a thing. In this case, your head, because you're wearing it. And you can detect if you're interacting or if you're hitting anything. Are you hitting another object? Are you hitting another part of the spatial mapping or whatever it might be? So that's the key to it. I'll see if I can show you a bit of it. So we have a Microsoft example, which I tend to use. Let me just start up the emulator here before we do anything. Okay, so Unity looks like this. Whoops, yeah, like that. And there's a ton of stuff going on, right? But this is what you need to kind of get used to. This is where you live a lot of the time, more so than Visual Studio. So you have various sections. You have, what the scene looks like, what you see out of the actual HoloLens, more or less. Obviously, the black part of this will be the transparent part, so that's where you'll see the real world. You'll have some, a hierarchy and some assets. In this case, there's my origami, so I can click on the stage and you can see that's the stage. There's some spheres. I can double click on those and zoom in and see them and stuff like that. It's quite good. Unity is a good tool. It just takes a little while to get used to it, as anything. This thing here is what really, really frustrates everybody, because everything you click on, that changes. So you have this, then it changes, and the camera, then it changes something else, and you got the cursor, and it just keeps going, right? There's just properties, 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 properties. I've gotten used to just ignoring it and knowing I need to fix this one thing. So let's go back and just see what. Okay, what is that doing? So I'm just wanting to start up the emulator here, which didn't work. Oh, of course I used the wrong one. So this is another part of it here. So there we go. The way it works is that you build everything in Unity, and you then write your C# scripts. So are people here familiar with C#? Yeah, a little bit, because I got that this was more of a C++ kind of crowd. Is that right? Python maybe, but embedded at least. C, C++, that sort of stuff. This is a Microsoft device. It uses C#. That's just how it is. Runs on .NET. But you build everything in Unity. I'll go back to Unity here. And you then export this as a project or solution into Visual Studio. And then you then take that and build it in Visual Studio, and then either launch it on the emulator or push it onto a real device or publish it, whatever. It's pretty freaking awful, if you ask me. They have done some improvements on it, like you can now run what's called a simulation in Unity for HoloLens so that you can just press the play button and it gives you most of what the emulator does, which is an improvement. But the development cycle is really long, and you're just going to have to get used to it if you want to try it out. You learn to do other stuff while you're exporting and importing and publishing and pushing and everything. Okay, so here's the emulator. Ooh, we've got sound as well. I might just turn the sound off for a minute. It'll become obvious why. So that's essentially that's what you see through the HoloLens, right? This is as close as you get without having a real device. So there's the spatial mapping. You saw the room behind it. There's an actual, virtual room that it uses. And we'll just see if that ran, got deployed. So then you get this. You get the whole gamut now. Oh, it died. You get an error because it took too long. So then we go back in again and then deploy it. So I'm not going to sugarcoat any of this and say, oh, it's all awesome. We all know as developers that some of it's just crap, right? But the end result is so amazing that you just keep pushing through, right? It's so convincing what you actually get to build. So while this is doing its thing, let us look at the code. So we're talking about gaze. And in this case, we have a cursor, which is this up here, world cursor. There's a script to be attached to the the digital object, the 3D cursor that we have, which I can just show you as well. It's a little bit odd because I have the computer over here. So anyway, bear with me. In here, I have the cursor. I can just double click it. Looks like that, right? So that's the thing I want to point with when I point with my head. And I want to attach a script to it called world cursor. And in this script, I'll just go through the main component here. There. There's a start. This is important. There's a start function and there's an update function. The start is what initializes everything when you start up the experience. When the hologram or the 3D object is initialized, it runs on start, just once. Update runs every single frame. Whenever there's a 60 times a second, 60 hertz device, it'll run through this code. So in here we have the raycast that we were talking about before, right? That's where it happens. So we get the head position and the gaze direction because the head is what we're looking with, right? That's where we're casting the ray from. I'll be looking at something. And then we do a raycast with that information. If we hit anything, that returns a Boolean, and we get this hit info object. And we can use that to know what we hit. We can interact with the thing that we hit. And in this case, we enable the mesh render. That means we're rendering, we're drawing the thing, the cursor. Then we set the cursor's position to wherever we got the hit, the point of the hit. And then there's this magic thing down here where we rotate it because we want the cursor to hug whatever it is on. And that's the quaternion function that allows you to do that. And if we don't hit anything, we just disable the cursor. That's all it does, right? So let's see if we got this running, hopefully. So here's origami. And it's a Windows 10 start menu as well. So then that starts up. And hopefully, there we go, made with Unity. And here's our little origami. So I'm controlling this with the arrow keys and WASD for a 3D experience, right? Now we were talking about the cursor. So that's the center of my vision, not the little cursor there, because that's just my mouse cursor. But if I turn over to that ball, oh, there's the cursor, right? And see how it hugs the surface of the thing, of the ball? So that's what we just did. That's all the code we needed. Pretty straightforward. So that's gaze. We look at something and we can then interact. We can interact with it. We can identify it. We can do whatever we need to. Okay. The next part of this is any questions? Like, you really can ask questions. I wasn't kidding. Or you can just be Norwegian. So gestures is the next thing. So we had gaze. The second of the 5 pillars is gestures. And it's kind of like this almost. We have a gesture frame. So in front of this, when you wear it, there's a gesture frame where it captures the gestures. And it's meant for you to just hold your arm relaxed at the side and do this, the tap. And it takes a little while to get used to because you see something and you want to tap it, or you want to tap it, or there's many, many versions of it. But the idea is that it's relaxed, you just do this. And that's what's meant to be a natural interaction, which it just isn't. Like, no one does this in real life. But you get the idea, right? We got this, the tap, which in my second session today we'll expand on a bit. There's a few other ways you can use it. And then you have bloom, which is like that, like a flower that blooms. And that's how to exit an app or bring up the start menu. Those are the only two you need to know. There's only two, right? So what's the natural question that everybody normally asks? Exactly. Can you build your own? Right? Can you make your own gesture? Yes, you can. Would you do it? No, never. It's really difficult because you have to manage all of the raw data that comes in from whatever the hands are doing. And then you have to accurately manage that into a gesture that might be a swipe or whatever it is you want to do. And then you get into the position of, well, how the hell does your user know that there's an extra gesture? Because everybody's used to this, right? So I would never, ever recommend doing your own gestures. Yes, you can, but you need a really good reason to do it. So that's the gestures. The code for this is almost as rudimentary. Oh, we'll get to that in a second. So we have what's called a gesture manager up here. Gaze gesture manager, which is a framework construct. Can you see this code? Is that all right? I can make it bigger, but the room's not that big. It's okay? Yeah? All right. And we use this gaze gesture manager to attach events to, essentially. That does all the hard lifting for you. It recognizes all the different gestures and throws events when something happens, right? So you don't have to worry about actually recognizing any gestures. You just need that manager. What we're doing here is we want to know if we're looking at something. So we have a focused object, which is just a game object, which is the lowest form of a Unity object is called game object. It's kind of like object in .NET. And in the start, we set up this tabbed event, right? So here's the recognizer, .tabbed event. That's it. Now you're listening for a tab, right? That's all you need to do. It really is that basic. And we have an anonymous function here that we say if we have a focused object, then we send it a message called onSelect. Like we're sending an event to whatever it is we're tapping on. And then, of course, you got to start capturing gestures. This is the most common thing that people forget to call, and then they don't know why it's not working. Then every single frame, we obviously want to know when we tapped on something if we're hitting it. Like, I mean, this should look pretty familiar by now. It's a raycast, right? So we're just doing a raycast again. And then if we hit something, well, we set the focused object to whatever it is we collided with. That's the beauty of Unity. Although everything is scripts and nothing really know about each other, you can get a reference to everything within your scene, within the experience, quite easily. And if we're not hitting anything, well, we set the focus object to null. We don't want to tap anything, obviously. And then there's some plumbing down there, right? And this means that we now, in here, so the tap on my emulator is just enter. Okay, so I'm just going to press enter. So when oh, sorry, I forgot. One more thing. Obviously, you want to look at what the event is, the onSelect. So each of the spheres has the sphere command script attached to them. And the onSelect here is what happens. There's a thing called rigid body, which, as you can see right now, they're floating. They're not actually doing anything. They're just kind of sitting there. Rigid body means apply physics or give it mass and weight and all that. So we add that component, and then we have a collision detection mode is, you know, how do we actually detect whether there's a collision with other objects, which is not too relevant in this case. And then we'll get to this. That's another part. That's for the voice in a minute. But what we then have is that what happens when you tap on it?
Physics are applied.
Physics are applied, and then what happens?
It drops.
It drops, exactly. So I'll just move out a little bit so we can actually see what happens. So now I tap on it, and it falls down, right? I didn't do any of the physics. I didn't code any of the rolling of it. I didn't code any of that. All I did was say I want a tap event, and when I tap on the thing, I give it rigid body. That's pretty much all I did. And you get this very natural, very kind of smooth and nice experience. I'll just tap on the other one, just for good measure, right? Bang, that falls down as well. And it falls into the abyss, because I'm not adhering to spatial mapping right now. So that's gestures. There's others that I'll go through in the other session, but that's it.
Are you planning are Microsoft planning any other gestures? You don't recommend making your own.
Uh-huh.
When the new one with the expanded view and everything comes out.
What, you know something I don't. There's a new one.
I
I know what you're saying. I don't know what Microsoft's planning, to be honest. I would imagine that there would be other gestures, like the swipe. I can see that's handy, like get rid of something, sort of thing. But I don't know. I think it's pretty difficult to do it consistently. And I don't know when there's a version 2 of this either, or 3, whatever they call it. That was not very helpful, was it? Voice is the third of the input methods that you can use. So there's gaze, gesture, voice, right? And there's something you get for free. You can say select on anything, which is the same as tapping. If there's a word at a button like this, if it says zoom there, you can just say zoom when you look or when you gaze at the application, and it'll just trigger it. There's a few shortcuts like that. You can use Cortana, which I know is really popular in Norway. No one here uses Cortana, do they? No, exactly. But it does work really well. There's a whole API for Cortana that's magnificent. Very easy to use voice recognition. And of course, you can use custom commands. You can do your own. Like you can roll your own commands, which is what we'll do. So, back to our script. So we have a speech manager. And I said you can use any voice command you want, right? And you can. And again, in the second session, I'll tell you why you shouldn't use any you can think of. So again, in the start, we set up a speech manager, keyword recognizer in the speech manager. And that just has a dictionary of keywords and values. The values are actions. So we're going to set up one here called reset world, and that'll broadcast a message called on reset, so we need to handle that. And then we have a drop sphere, which will send an on drop to whatever we're looking at. And then we give those keywords to the keyword recognizer, and then we start it, which you can't see, down there. And then when we have a phrase that's recognized, then we invoke that keyword, that action, the value of the dictionary. So there's just an invoke function. And this might be a little bit quick, but we don't have that much time. And if you've done any sort of C#, this should be pretty straightforward. So back to our sphere commands here, because that's what's going to, collected. On reset, when we get that, we destroy the rigid body, so we destroy the object, right? And then we put it back to its original position, which we recorded when we initialize it. So we can put it back up. And when we call on drop, we just call on select, which was the same as when we tapped, right? So we just reuse that function. And then we'll see if this works. Reset world. Hey, and it came back, right? So that's voice command. Again, I'm using the emulator, so it's my laptop microphone, but it works. So then if I look at something like this one here, I can say drop sphere. And it falls down. That's it. That's all you have to do with voice commands. Like, it really is that easy. This is kind of, if you've never done development for it and you start looking and you go, is that it? It's kind of almost, it's what Venkat was saying this morning. It's too simple. You don't feel like you achieved enough, right? But it really is that simple. And then we'll look at the fourth part of this. So that's gaze, gesture, and voice, GGV for short. Those are the input methods. Then you have sound, right? And sound is often something we don't really understand how to do it unless we're an audio engineer, which most of us aren't. So we kind of just put it in there. And that's a pity, because it is using what's called head-related transfer function. And I won't go into detail exactly what it is. You can Wikipedia, which is what I did. But it's a way of calculating how a sound reaches your two ears. And this is what they use for these little speakers. And it's really convincing. It's very, very good. But you don't have to do any of the mathematics. It's all done for you. All you do is you attach sound to a thing. And we'll go back to the code. Now I want to go just to Unity first here. Come on. So in Unity on our origami collection, unfortunately I can't zoom in more than this. This is just how it is. We have this audio source, which comes from an asset here, and you just drag and drop. This is the beauty of programming in Unity. You take this and you drag it and you drop it on there, right? That's it. Or you can drag it over here, you can drag it over here. But essentially that's how you attach things to each other. And we have this audio source, And the reason I put my computer on mute before, you'll realize in a minute, was because this is freaking annoying, but this is the demo that it is. We have this audio source, which is the ambient noise. And I will now, are you ready? I know. I know. Reset world. Still works. And now, if I've done this correct, whoop, there it is. Oh, isn't that lovely? That's the sound script that's attached to the spheres. I'm sorry. It's just, it's another one of my little pet peeves. Don't ever have background music, right? It drives people mad. Remember, they have this on their head. They cannot escape, right? There's no background. So the code for this, again, it's almost not worth looking at, to be honest, because the sphere sounds here is just setting up an audio source and a clip. You have some of these values that if you understand what they do, you can set them or not. You load an impact and a rolling clip, and then you have some collisions and you trigger the sound, right? And these on collision enter and exit are built in the Unity framework. You get those for free. They'll be triggered every time there's a collision, and you can handle it or not. But you can probably come up with better sounds than that. Because in my workshop, I have we shoot down some cardboard boxes with balls. You know, as you tap, you shoot a ball. And I found a sound bite of someone cutting up a cardboard box, and I cut that into 4 pieces, and it sounds infinitely better than that. And that was my 10 minutes. So you can definitely come up with better sounds than that. But sound is hard. Bunch of code on when do you roll it, you know, how much magnitude, velocity stuff do you need for it to play the rolling sound, all that stuff. But that's, you can go into any kind of detail on your sound design. Okay, because I want to show you how this works, right? So let's just do a demo of this. And I just need to make sure that I am, so now I'm going to connect both of them to my own hotspot, because you need the smallest possible network in order for this to not have a million seconds of lag. So let me just do that. It's me. There we go. Okay. So, come on. So I'll make sure it's connected to my phone. Yep, very good. Okay. So, here's a little developer tool. We'll look at that more in the second part as well. Oh, decided to log out. Just go back in. Okay. So now, talk amongst yourselves. Come on. So I have a floating start menu in front of me now, which you can't see, but it's a bit weird. I can actually just remove it, get rid of it. There we go. Now this is not going to won't do anything. Come on. Yes. Might just try again. Ooh. Wow, crashed the whole thing. Oh, Chrome doesn't work. What a surprise. Come on. There we go. Chrome says not secure. Oops. It's interesting typing with this on because you can't really see everything. There we go. Ah. There we go. Okay. Now we can do it. So I can do a live preview, which means you can see what I see. There we go. It is a little bit flaky because it depends on network and how much interference there is and everything. So now you can see what I see. Kind of, right? It's a little bit of a lag, a couple of seconds. So this is a game called Robo Raid, and I kind of cheated and started a little bit before. So is that hole and roll? You can see inside the wall. And it's like it's there, right? So now I go, oh, whiteboard's getting, oh, there's a robot coming out the whiteboard. So you shoot the little robots that come out. Shoo, shoo. And then depending on how good or bad your mapping is, which this is terrible, obviously, because I haven't mapped the whole room. But the cool thing is you can shoot everything, right? You can shoot walls, and it's just like you're shooting it real. And I can go and look at the wall, and look inside of it. And it's a lot more stable in the goggles than it is for you guys on the screen, just because I move my head a lot more. So we exit that. Gives you an idea, right? Now everybody likes unicorns, right? Yes? Okay. Who wants a unicorn? Jeez. Wow. You can get a cat as well. Or maybe a space helmet. There you go. Hey. There you go. Look at that. Nice. There you go. You got a helmet. And this is just a bit of fun, right? Now, do you notice the thing with, as fun as this is, there you go, got big eyes. Is this mixed reality? Not really, is it? I'm just placing things around the room. Oh, we can put a monkey on the floor here. But they're all floating. They're not actually adhering to anything. I can place them wherever I want. They don't fall down or anything. Actually, I think this guy needs to be huge. There we go. Monkey's a lot bigger. Hey, look at that. Down. And the cool thing is I can move around everything, right? And I can see it from every angle. Oh, I'm behind the thing now. There's the thing. There's the monkey over there. And it's super, super stable. Like, it's unbelievably stable, actually. Ooh. There you go. All right. Cool. So that is all we had time for. But, as I said, you're more than welcome to try it if you want. I've just got a couple of little slides here. Any questions on that? Does that feel convincing? Yeah?
How complex scenes can you render in the glasses before it gets too overwhelming for hardware?
How complex can the scene be before you're overwhelmed or the device is overwhelmed? The device. I haven't reached the limit yet. Having said that, in the workshop yesterday, the guys did something where they built this, well, essentially they built a shooting range. I don't know what they did, but they managed to make the frame rate really crap. So there was some performance issue there, but I'm not sure. But in general, if you do it correctly, there's not a limit. Like these holograms, you can put hundreds of them. Like it just knows where they are. And they stay there. Like if I turn it off now and I go back to Australia, come back next week, they'll still be here. All right, so you got to clean up your shit. Okay, so what's next? There's some social issues around it. I hope we don't get to this part anytime soon, because that would be a bit scary, or awkward, I guess. As you may have noticed, you do look like a bit of an idiot with it on. It's not a great look. I don't know if I had to do that. And often you see these elements, you see these kind of huge endeavors of this is all of the data of Mars that you can go and look at, right? We don't have this as hobbyists or little companies or big companies. We don't have this enormous amount of data. So I think there's a much bigger chance that this evolvement is going to come through tinkering. People are going to sit here and they're going to build little things. They're going to try and evolve some little idea they have, whatever it might be. The tinkerer, I think, is much more important for the success of the device, not necessarily the marketing of it. You can absolutely just go and do it now. The origami tutorial we looked at, it's on the Microsoft website, on the developer portal. Try and find a 3D modeler if you're serious about it. There's an asset store Unity that you can use. Yes, it's expensive. It's crazy money. $3,000 US, which is that in pounds. Now, I just want to show you a little bit of an example of this tinkering. I know we're running a little bit over time, but I hope you can bear with me. Oh, I need sound. Oh, hang on. That has got to go. This is so annoying. Okay, let's just try it again. There we go. So this guy here.
What I think I'm going to do, I think I'm going to just simply put a sphere in the middle of the bush and then just go around it and see what areas are outside the sphere and just trim them. And I don't know, let's see what happens. I'm gonna try it out and show you guys whenever I get it done. So, this is what it looks like after trimming. I think I did a pretty decent job. Let me show you without the sphere, which by the way is low polygon, so it's not quite spherical, so it's not that great. And I could, you know, keep going if I wanted to, but that's good enough. So this is what it looks like. I think it's pretty good. I just needed to grow a little bit more so I can trim it a little better, but I'm pretty happy with it. And that's how HoloLens can help you
Do gardening. Who would have known? Really simple idea, right? He just takes, this is a built-in tool, he places a sphere and that's it. He just has an idea of, hey, this can help me do something cool. And I think that's much more valid for us as, you know, developers and tinkerers and everything, more so than this huge NASA experience or Mars experience or Fragments, which is a game on here that's hugely impressive, but we probably wouldn't build a game like that. Depending on whether you want to quit or not, I've got one more demo of what is the future of this device. So I think this is worth, I know I'm 3 minutes over time, but this is very, very cool.
Hi, today we're going to show you an exciting new technology that could fundamentally change the way that people will communicate in the future. Imagine being able to virtually teleport from one space to another in real time. Hey Sergio, how does it feel like to be holoported?
It feels great to be holoported.
So Sergio is to wear his HoloLens device, and I'm going to wear mine. We can see each other in full 3D in real time. We can interact and communicate as if we're co-present. Sergio, can you walk around my space? Can you walk behind this chair? So we're doing everything to give the impression that Sergio and I are present in the same space. Sergio, let's just do a high five. That's great. Thank you, Sergio. We call this technology holoportation.
And that's cool, that's useful, right? Now I'm pretty sure the other guys in the next room, I don't think it's across the country, and look at the amount of cameras they have, but they're doing it. And they're now actually done this in a moving car. So the guy being holoported is in a moving car. Like he's not driving it, he's in the back, but he's being, you know, it's very, very impressive. That's me. I'm MVP for Microsoft, they give me stickers. I have a blog if you want to read more about some of all this stuff. I do a bunch of Pluralsight courses, which are these. I have one on HoloLens development as well. It's a mixed reality and tooling and everything else. I have a podcast if you want to hear more of my ramblings with a guy I've never met in Alaska, which is kind of interesting. And please come tonight for the party, right? There's this dude, Tom Haslin. He's apparently really good. I don't know who it is, but he's a jazz musician. And if you want to stay on, I'm doing a next session in this room in about 10 minutes on a bit more in depth on all the stuff of this. This one went a bit quick. Thank you.